Welcome to another video. Today we will be looking on inequalities. So inequalities is just a comparison of two quantities. And for those persons who it is the first time that you're hearing the word inequality, you would have seen two symbols. So the first one here, which means less than, and the second one, which means greater than. So which one of these symbols would be correct? Less than or greater than? So we're comparing two quantities, 5 and 4, and want to make the statement true. So one way in which you can remember which one of the symbols to use is that the opening of the symbol normally points to the greater or the bigger quantity. All right, so we always say that the symbol is an alligator mouth or a crocodile mouth. Crocodile mouth normally open to the bigger quantity. So the bigger quantity in this case would be the 5. Therefore, we'll use the symbol which opens to the 5, so the greater than. So now we can read this statement as 5 is greater than 4. So the quantity 5 is actually greater than the quantity 4. Let's look quickly at another example. So what if we have two more quantities, 3 and 10? So realize that the 10 is bigger than the 3. Therefore, we would use a less than symbol. So we use a symbol that opens to the bigger quantity, which is a 10. So this will now read 3 is less than 10, which makes the statement true. So 3 is less than 10. And we always could swap these numbers around. So we can put the 10 first and the 3 second. And therefore, because the 10 is first, we'd have to use the symbol that opens the 10. So then now the symbol would change from a less than to a greater than. So 10 is greater than 3. So this is how we use the symbols. So these are the two symbols that most persons would be used to. But with inequalities, there are two more symbols that you will see. So those are the less than or equal to symbol and the greater than or equal to. So there are 4 symbols, and there's also a not equal to. There are actually 5 symbols, but you mainly see the first 4 being used. So let's look on this inequality here. So we have x is less than or equal to 10. So we don't know what the quantity of x is, but it is based on the statement here. It says that whatever x is, it is less than or equal to 10. So it can be it can be equal to 10, or it can be a number that is less than 10. And let me also point out that it doesn't have to be an integer. It can be rational numbers. So x can be 9.9, 9.5, 9.1. It can be 8.5. It can be 0. It can be -5, -1.5, go on. Yes? So we're going to represent this inequality. X is less than or equal to 10 on a number line. So here's our number line right here. So we're going to number a number line. So the 0 doesn't have to be in the center. So I'm going to start numbering from 7. We want to represent this inequality right here. X is less than or equal to 10. So we know that we say that the value of x has to be either 10 or less. So it would be one of these values to the left of the 10, inclusive of 10. So to show that or represent that on the number line, we normally use a shaded circle, which means that the value is included. So whatever x is, it can be 10 and it can be less than 10. So we're going to draw an arrow to the left to show that value of x can be 10 or less than 10. So it's a shaded circle because it is less than or equal to, and our arrow will point to the left because we want to make the inequality true. So here's another example. We have -3 is less than m. So we see that the variable is on the right hand side. What does this mean? -3 is less than m. So it is telling us that whatever m is greater than -3. So we now can say that whatever m is, it has to be more than -3. So it can be -2, -1.5, it can be 0, it can be 1, 2, 3, all the way to positive infinity. And we can always just flip this around. So we can write our m and our -3, switch positions and also switch our sign. So this is the same thing. And whatever the quantity of m is, it is greater than a -3. So let's go ahead and graph this on our number line. So we're going to write in our values. So our value that we have here is -3. So we're going to put our circle there because it is a less than or greater than symbol. So it means that the value, so -3 is not included. So it's going to be an open circle. And looking on this one right here, it says that m is greater than -3. So it means that whatever m is, it has to be, so it's to the right side. So therefore, we're going to draw an arrow to the right. So here we have made our inequality statement true. So let's conclude before we go on to solving some inequalities. So representing inequalities on a number line, if the circle is shaded, it means that the value is included. So once you are using the symbol greater than or equal to or less than or equal to, so one of the symbols with the equal to, then the circle has to be shaded. If it's an unshaded circle, then it means that the value is not included. So anytime you're given just a normal greater than or less than symbol, then you know that the circle must be unshaded. Our arrow will go to the right if the value is greater than or equal to, and the value will go on our line, and our line will go to the left if the value is less than or equal to. Let's go ahead and solve some inequalities. So here we have 2x is greater than 6. So we want to simplify this and then graph it on our number line. Inequalities is something similar to equations. It's just that instead of an equal sign, we have one of these symbols here. But the same rules still apply. So whatever we do on one side, we have to do it on the other side. So we want to get the variable by itself, but we have a 2 being multiplied by the variable. So in order to get rid of this 2 that is multiplied by the variable x, we have to do the opposite operation, which is divide by 2. And whatever we do on one side, we have to do it on the other side. So 2 into 2, we're left with x. We write back our greater than sign, and 2 into 6, 2 into 2 one time, 2 into 6 three times, so we're left with 3. So x is greater than 3. So we're going to go ahead and draw up our number line. So let's go. So our value here is 3. So we know that our circle will be at 3. It's a greater than sign. We don't have the equal to there, so our circle will not be shaded. And when we look on this inequality, it says we see that the opening is to the variable. So we know that the variable, whatever the x is, it is more than 3. Therefore, we know that our answer would lie to the right of the 3. So 3 is not included, but x can either be 3.5, it can be 4, it can be 10, it can be a million, it can be any number going to positive infinity. Let's look at another example. So here we have a little bit more complex inequality. We want to get the variable by itself on one side of the inequality. So we're going to start from the one that is easiest to move. So this plus 2 right here, we want to get rid of that. And the only way we can get rid of this plus 2 is by subtracting 2 on both sides. So this will give us 0, so we're left with -2x. Write back our inequality symbol, so greater than or equal to, just -8. So we have gotten rid of this plus 2. Now we need to get rid of the -2. So to get rid of the -2, we have to divide both sides by -2. Now here is a little trick. So whenever you multiply or divide an inequality by a negative number, you have to swap or reverse the symbol. right? So we're going to reverse the symbol. So it's going to become a less than or equal to symbol. And this will be x, will give us a positive 4. Therefore, answer is x is less than or equal to 4. All right, so we're going to go ahead and graph this on our number line. So we have our number line. Our value here is 4. It's a less than or equal to, so we know that it's a shaded circle. So it says x is less than or equal to 4. So we know that whatever x is, it can be 4, or it has to be a value that is less than 4. So our arrow should point to the left. So our value x can be 3.5, it can be a 1, it can be negative 2, negative 4.5, negative a half. Any number going all the way to negative infinity can be our value of x. Our final example is negative 5 is greater than 10y over 4. So we see that the variable is on the right hand side. Don't get nervous. Same concept, same procedure. So we want to get the variable by itself. So we are going to try to remove the one that is easiest to get rid of, which would be our 4 that is divided by the 10y. So to get rid of that 4, we have to multiply both sides by 4. So this will cancel the 4, so we're left with 10y, and 4 times negative 5 will give us negative 20. So we get rid of the 4, now we want to get rid of the 10 multiplying by the y, so we divide both sides by 10. 2 is greater than y. We can rewrite this as y is less than negative 2. Both of them are saying the same thing. So we're going to go ahead and represent this on our number line. So our number is negative 2. It's a we don't have an equal to on the symbols, so we know that the circle is going to be open. And looking on this one right here, it says y is less than negative 2. So the arrow would have to point to the left to make that statement visually correct. Now it's your turn. So here are 4 questions. Want you to attempt them. So pause the video, attempt them, and then resume the video to look on the working out of these questions.